Hi, welcome to C in Calculus. In this video we'll be covering derivatives and operations. So we'll be doing addition, subtraction, multiplication, and division. Now it's not too much harder than what we did previously. However, we have to make sure we take our time so that we don't get things confused. We'll start with addition. If we have two things, f of x plus g of x, to take the derivative, we can either add them first and then take the derivative, or we can take the derivative of each of them and then add them. I'll show you both ways. So we have 3x plus 8x. We're going to first add them first. So 3x plus 8x is 11x. Then we're going to take the derivative, and when you take the derivative of 11x, you just cross off this x, you get 11. Let's try the other way. First take the derivative of 3x, which is 3, then the derivative of 8x, which is 8. Add them, you get the same 11. Let's look at the next example. 5x plus 7x. We're going to take the derivative of each of them first. So the derivative of 5x is 5, and the derivative of 7x is 7. You add them and you get 12. Now let's try it the other way, where we're going to add them first and then take the derivative. So 5x plus 7x is 12x, and the derivative of that is going to give you 12. Addition is very straightforward, and subtraction follows the same pattern as well. In subtraction, if you're subtracting two things, the way you would do it is you either subtract them first and then take the derivative, or take the derivative first and then subtract them. In this example, 9x minus 5x, we're going to first subtract both of them. So 9x minus 5x is going to give us 4x. Now we're going to take the derivative of that, and it's going to give us 4. Over here, we're going to take the derivative of each item separately and then subtract them. So the derivative of 9x is going to be 9, and the derivative of 5x is going to be 5. Now 9 minus 5 is 4. So addition and subtraction are pretty straightforward. Let's move on to multiplication, which is a little bit more complicated. In multiplication, when we have two things being multiplied, we first take the derivative of the first thing times the regular second thing, add it to the regular first thing times the derivative of the second thing. So in this example, 7x times e to the x, what we want to do is see where the multiplication is happening, and it's happening between the 7x and the e to the x. So the first part of it we're just going to call 7x. It's important to label what's the first part and what's the second part. So since the first part is 7x, the derivative of that is just going to be 7. So 7. We're going to that spot. Now e to the x is its own derivative. In other words, if you take the derivative of e to the x, you'll get back e to the x. That's a funny thing that you'll see worked out more later on. So now the regular second thing is just going to be e to the x plus the first item, which is just 7x, times the derivative of the second item, which is e to the x. So we're really just plugging in into this formula so we get this fashion. Now moving on to the next example, 9x times sine of x. We want to see where the multiplication is, and it's right between the 9x and then the sine x. So the derivative of the first term is 9, because 9x, you just cross off the x, you get a 9, times the regular second term is going to be sine of x. Now sine, when you take the derivative of it, sine is a curve, and the derivative of the sine curve is cosine. Later on we'll see more examples of it, and I'll explain it a little bit more. So after we did the first half, we're going to do the second half. So we take the regular first term, which is just 9x, times the derivative of the second term, and as I just said, the derivative of sine of x is cosine x. So our answer is 9 sine x plus 9x cosine x. So to review, we're going to take 9x, which is the first half, take the derivative, which gives us a 9, times the regular second half. Then you add it to the regular first half, which is 9x, times the derivative of the second half, which would be the derivative of sine of x, which is cosine x. So then this is our answer. The derivative of 9x sine x is going to be 9 sine x plus 9x cosine x. Now we'll move on to division. But first, I'll do one more example for you. So, if we have 13 times sine of x, we want to first identify where the multiplication sign is, and it's right here. This is slightly different than our last example. So we're going to take the derivative of the first section, which is the derivative of 13. Now 13 is just a number. There's no x after it. It's just a number. It'll be the horizontal line I showed you in the first video. So the derivative of 13 is 0. Then we're going to multiply that times the second term, sine of x, and add that to the regular first term, which is 13, times the derivative of the second. And the derivative of the second of sine x is going to be cosine x. So our answer is 13 cosine x. So 13 sine x, when you take the derivative of that, you get 13 cosine x. Now, moving on to division. Division is where you really have to be careful to not mix up your orders and to keep everything separate. So when you have division, you'll have something on the top and something on the bottom. For the purpose of this, I call it f of x and g of x. So, but I could have put r of x or g of z. The letters don't matter too much. So we're going to take the derivative of the top item, the f of x, times the regular bottom. You're going to do subtraction. Then you're going to take the regular top, regular f of x, times the derivative of the bottom. And all of that is going to be over the bottom squared. So you can either express it as f prime of x times g of x, or you can use a notation where I'm saying top and bottom, whichever helps you to remember it. Just remember that it's going to be the top one with its derivative taken times the bottom one, and then you continue here. So let's do an example. We have 8x to the 8th divided by sine of x. The best way I found to do this, and with teaching students, is to make a little toolbox to keep everything separate, so that you just have to plug in your answers and all your work is done separately. So usually I would keep this right here to the side. So, and it's a list of what I know. So f of x is equal to x to the 8th. That's stated in a problem. The top and the bottom is equal to sine of x. That's stated. Now we're going to do the derivative of the top, which is going to give us 8x to the 7th, because 8 goes to the front, it gives you 8x. You subtract 1 from the 8 to give you 7. Now the bottom, which is sine of x, the derivative of that is cosine of x. Now that we did the work, we just plug it in. So we're going to put the derivative of the top, boom, right here, which is going to be 8x to the 7th, times the bottom is here, boom, sine of x. Then you can do minus the regular top, right here, boom, times the derivative of the bottom. You put that there, and then you just put the bottom squared. I'll do another example. In this one we have 7x to the 5th divided by 5x times e to the x. Let's have our little toolbox here again. Okay, so f of x, or the top, is just 7x to the 5th. The derivative of that will be 35x to the 4th, because 5 times 7 is 35, and 5 minus 1 is 4, so we get that. And the bottom is just 5x times e to the x. Now the derivative of the bottom is a little bit trickier. We'll have to use the product rule that we just learned, so I'll review that with you. So first we take the beginning part, which is the 5x, take the derivative of that, and it's going to be 5. Then it's going to be times the regular second, which is e to the x, now plus the regular first, 5x, times the derivative of second, e to the x. So right here we did the product rule. And this is why I was saying it gets a little bit tricky, because during the divisions and during the more complicated derivatives, you'll be doing quotient rules inside of product rules. You'll be doing all of these different things, and you want to make sure you keep them separately written. So now we just plug in. So we're going to plug in the derivative at the top, which is going to be this 35x to the fourth, times the bottom, which is 5x e to the x. Then you can do minus the regular top, which is right here, 7x to the fifth, times the derivative of the bottom, which is what we did with the product rule, and we put it right here. Now we're going to divide that by 5x e to the x squared. So now you can simplify the bottom to make it say 25x e to the 2x, whatever you choose to do. But for the purpose of this, we don't have to simplify it. So those are the basics when you're using the for operations. I'll have more examples posted on CN Calculus. Now, as you can see, we started off very simply by taking the derivative of constants, and we moved on so quickly to these quotients. So if you're trying to keep up, if you don't understand everything fully, I think you should watch the videos again, and it'll just become clearer. You can watch this video as many times as you like, or the one previous to it. Watching them over again will help you to build a strong foundation, and a strong foundation is key. And like I said, with these derivatives, you want to make sure you keep them separated, you write neatly, and you just do it step by step. If you understand everything and you're ready for the next video, alright, let's go. CN Calculus, derivatives.